Okay, let's solve one more problem on equilibrium. So the problem is very much similar to the previous example, just that instead of a hinge, we have this being supported by friction. So there is friction between the wall and the beam. So mu s, let's say, is 0.3. So 0.3 is the coefficient of friction, of static friction between the wall and the beam, and it's the friction that is trying to support the wall, the beam from sliding downwards. So because if there is no friction present, then um, the beam is going to slide downwards and the system will not be in equilibrium. But if there is friction present, the friction can stop this part of the beam from sliding downwards and can provide equilibrium to the system. But the question is that with this kind of setup, is this setup really in equilibrium? So the question is this setup in equilibrium? What does that mean? It means really sum of all the forces equals 0, sum of all the forces in the y direction is equal to 0, and sum of all the torques equal to 0. By torque we mean torque will be, you see, if you use your right hand thumb rule, torque will be in the z direction, because I will talk about that more, but right now. So let's test these conditions. So beginning with this equation, first of all we have to make free body diagram. So let's make free body diagram. We know there is a force of gravity acting downward, which is mg. There is a tension acting, which we know can be broken down into T sine 30 degrees and T cos 30 degrees. And we also know there is a force of friction which is acting, let's call it Fr, and we know there is a normal reaction acting, right? Because normal reaction acts perpendicular to the surface, and this is the surface we are talking about, so there is a normal reaction. We already have defined our x-axis and y-axis, so sum of fx in this equals 0. So let's write that equation, which means n minus t cos 30 degree equals 0. Let's call this 1, 2, and 3. So second turns out to be t sine 30 degrees plus Fr minus mg equals 0. And the third one, you see, this guy t sine 30 degrees will move or rotate the beam in the counterclockwise direction or anti-clockwise direction, and the torque is going to provide will be t sine 30 degrees times 2, and this guy will just do the opposite, so it will be mg times 1 equals 0. And now we can solve this and see that t turns out to be same as mg, right? Okay, so we have t. Now we can calculate n also. So n turns out to be t cos 30, which is going to be, we know cos 30 is root 3 over 2, so it's root 3 over 2 m times g, because t is nothing but mg. Okay, so we have n also. Also from here we can calculate Fr. So Fr is going to be mg minus t sine 30 degrees. So it's going to be mg minus sine 30 is half, so t is mg, so it gives mg over 2, and we get mg over 2. Okay, so this should be the friction present to support the beam. This is the amount of friction that should be present. Only then system will be in equilibrium and Fr. But we also know that the maximum value friction can achieve is mu n, mu Sn. So let's see what is the maximum value of friction. N we already know is root 3 over 2 mg. But looks like this value here is actually less than the required value. This is the required and this is the maximum friction, which is less than the required value, which means the system is not going to stay in equilibrium. Instead, the beam will slide down. So again, we just did the same thing, wrote the equations in terms of forces and torque, and solved the problem.